Hello, welcome once again. In this video series, we will see what is Niagara and how to use the Niagara system for creating excellent VFX. Niagara is Unreal Engine's next generation VFX system. With Niagara, the technical artist has the ability to create additional functionality on their own without the assistance of a programmer. The Niagara VFX system is one of two tools we can use to create visual effects inside Unreal Engine 4. Before Niagara, the primary way to create and edit visual effects in Unreal Engine was to use Cascade. We have made tutorial series for that also, and the link has been provided in the description. While Niagara has many of the same of particle manipulation methods that Cascade offers, the way we interact and build visual effects with Niagara is vastly different. Before we can begin to create visual effects using Niagara, we will need to enable it via the plugins menu. In this video, we go over what needs to be done in our Unreal Engine project so that we can use Niagara. Please like this video if you find it helpful and informative, and subscribe to our channel for newer updates and game development tutorials. So let's start. The Cascade to Niagara Converter plugin is a utility designed to convert any of our existing Cascade particle systems assets into equivalent Niagara systems assets. The plugin includes a blueprint function library to generate both Niagara Emitter and Niagara system assets. To enable the Cascade to Niagara Converter plugin for our project, we need to perform the following steps. First, navigate to Edit and then to Plugins in the main menu to open the Plugins browser tab. Second, from the built-in category side menu, navigate to FX and then Cascade to Niagara Converter plugin, and enable the plugin. When prompted, click Restart now for our changes to take effect. Convert our desired Cascade particle systems to a Niagara system by right-clicking on a Cascade particle in the content browser and selecting Convert to Niagara system from the context menu. A new Niagara system is created in the same directory as the source Cascade system with the suffix converted. Once the Unreal Engine editor has restarted, when we right-click in the content browser, we will have a new FX section that will have all of the various items we can use with Niagara. A commonly used visual effects technique that is rendered is called sprites. In this video, we will set up a Niagara emitter to work with sprites. When we place the Niagara system containing the Niagara emitter into a level, we will see the effect displayed in that level. However, we have some prerequisites for this. We need the m_smoke_sub-UV material, which can be found with the starter content. If we have not done so already, make sure that this material or the starter content has been added to our project. First, make a new folder in the content browser to hold the assets for our effect. Let's see the recommended workflow is to create a system from existing emitters or emitter templates. First, create a Niagara system by right-clicking in the content browser, and from the displayed menu select FX and then Niagara system. The Niagara system wizard displays. Select New System from selected emitters. Then click Next. Under Template, select Simple Sprite Burst. Click the plus sign icon to add the emitter to the list of emitters to add to the system. Then click Finish. Name the new system Smoke System. Double-click to open it in the Niagara editor. The emitter instance in our new system has the default name of Simple Sprite Burst. We can rename it, however. Click the name of the emitter instance in the system overview, and the field will become editable. This video, we will go through the emitter module groups as they appear in the stack. However, until we set our material in the renderer, we won't see anything in our preview or in our level. So first, in the system overview, select the sprite renderer to open it in the selection panel. This is where we select the material for our effect. Since the material is a sub-UV material, we need to tell the renderer how many images are in the image grid. Set the following properties to some certain values. Now we will edit the emitter update group settings. First, we will edit the modules in the emitter update group. These are behaviors that apply to the emitter and that update each frame. Here we want to create a constant column of smoke, not a burst of smoke. Click the trash can icon to delete the spawn burst instantaneous module. Now add the spawn rate module to the emitter update group by clicking the plus sign icon and selecting spawning and then spawn rate. Then in the spawn rate module, set the spawn rate to 50. This will give us a good-sized puffy shape made of smoke. This is a good start to our effect. For now, while we are building the effect, we want to set the simulation to run on an infinite loop. This gives us more time to evaluate how the settings are affecting the effect. In the emitter state module, click the drop-down for life cycle mode and select self. Then click the drop-down for loop behavior and select infinite. Now we will do the particle spawn group settings next. We will edit the modules in the particle spawn group. These are behaviors that apply to particles when they first spawn. In the system overview, click the particle spawn group to open it in the selection panel. First, expand the initialize particle module. This module collects several related parameters together in one module, minimizing clutter in our stack. Under point attributes, locate the lifetime parameter. The lifetime parameter determines how long particles will display before they disappear. Here we want a little randomness in the lifetime parameter to better simulate real smoke. Click the drop-down arrow next to lifetime and select dynamic inputs and then random range float. This adds minimum and maximum fields. Now set the lifetime minimum and maximum to the following values. Minimum 2, maximum 3. We are going to adjust the size of the sprite particles to continue making the smoke effect more realistic. The original bundle of particles is rather small, so we are now going to increase the size. We will also make the size a little random, so the sprite particles overlap and make a more consistent smoke effect. Under sprite attributes, locate the sprite size parameter and make sure it is enabled. Click the drop-down arrow next to sprite size and select dynamic inputs and then vector 2D from float. This replaces the sprite size X and Y fields with a single value field. Next we need to add another dynamic input to add randomness. Click the drop-down arrow next to value and type random in the search bar. Select random range float. This adds minimum and maximum fields to the value. Now set the minimum and maximum values for sprite size as minimum 75, maximum 200. So now we have a larger mass of smoke. Our result is getting closer to looking real. Now we are going to add some rotation to add more variation to the particle's shape. Additionally, we will add randomness to the rotation to increase the variation. Set the drop-down next to sprite rotation mode to direct normalized angle, that is 0 to 1. Next, click the downward arrow next to sprite rotation angle and select dynamic inputs and then normalized angle to degrees. This adds a normalized angle field. This means the rotation angle in degrees is converted to a decimal between 0 and 1. Now click the drop-down arrow next to normalized angle and select dynamic inputs and then random range float. This adds minimum and maximum fields to the normalized angle. The particles will rotate a random number of degrees when they spawn. Set the minimum and maximum values as minimum 1, maximum 2. So now we have a fairly good size cloud of smoke, but it is just spinning in place. We want the smoke particles to start moving as soon as they spawn. So now we will add some initial velocity. Add the add velocity module to the particle spawn group by clicking the plus sign icon and selecting velocity and then add velocity. Now click the drop-down arrow next to velocity and select dynamic inputs and then random range vector. This adds minimum and maximum fields to the velocity. Again, the slight randomness adds variation and naturalness to the effect. Set the velocity minimum and maximum values as minimum 0 to x and y and 50 to z and maximum x1, y1, and z 200. Sphere location controls the shape and origin of where sprites spawn. By adding a sphere location module, we can have the sprite spawn in a sphere shape and we can set a radius to determine the size. Add the sphere location module to the particle spawn section by clicking the plus sign icon and selecting location and then sphere location. Set the sphere radius to 64. Make sure the sphere distribution is set to random. The sprite material that we are using for this smoke effect uses a sprite sheet, which has multiple images that are designed to be strung together and animated. When we do not account for this, our renderer will only use the first sprite on the sheet. We can add a sub-UV animation module to solve this problem. Click the plus sign icon for particle spawn and select sub-UV and then sub-UV animation. In the sub-UV animation module, click the drop-down for sub-UV animation mode and select linear. For number of frames, type 64. The sprite sheet has an 8x8 grid of images, so the total number of images is 64. Now see the particle update group settings. Here we will edit the modules in the particle update group. These behaviors apply to particles and update each frame. The velocity we added in particle spawn gave our particles some movement when they initially spawn. Now we want to add movement over time, and we want the smoke to rise. Add the acceleration force module by clicking the plus sign icon for particle update and selecting forces and then acceleration force. Because Niagara adds new modules to the bottom of the group stack, we will get an error stating, the module has unmet dependencies. That is because the acceleration force module was placed after the solve forces and velocity module. Click the Fix Issue button to move the module. Leave the X and Y values set to 0 and the Z value to 500. This will give the smoke significant upward movement over time. We can adjust this setting or even remove this module depending on the type of smoke effect we want to create. If we want to be able to reuse the smoke emitter in our system, we can save it as a separate asset. Click the gear icon to open the emitter settings menu and select Create Asset from this. The result is an independent Niagara emitter asset. Then click the Save button to apply and save the changes. So, here is a simple smoke effect using sprites. Now let's drag the Niagara system onto the level. Here we are. When you make a particle effect, it is always a good idea to drag your system into your level. This gives you a chance to see every change and edit in context. Any changes you make to the system automatically propagate to the instance of the system at your level. Great. We have created a simple smoke effect using sprites. Hope this video will help you to initiate your journey into the creative world of Niagara. Thanks a lot. See you in the next video.